The topic in this video is using compound interest formulas, and we have an example. This should be a review from an earlier lesson in our chapter. So these formulas are already in your notes. The one on the left, the formula on the left, A equals P, quantity 1 plus R over N raised to the NT. These are what those pieces mean. And if you ever hear the word continuous, then you would use the PERT equation. Remember, E represents that approximate 2.71. So let's get into using that set of formulas. So we have $2,000. So that is our principal. An interest rate of 9%. So our R is going to be 0.09. You always move that to the left 2 places. Our time is 5 years. And we're going to compound it first quarterly. So that means our N is 4 in that formula. Quarterly means 4 times a year. Let's go ahead and plug in our pieces into our equation. A represents our end amount. Our principal of $2,000. That's our original. 1 plus, and then R over N, 0.09, divided by N. We had 4 compounds a year. This is compounded quarterly. Raised to the 4, and then times 5. So with orders of operations, we want to do our parentheses first. So I'm going to first divide 0.09 divided by 4. I'm going to add 1. So this parentheses now is 1.0225. Then I'm going to multiply 4 times 5 together, which is 20. And then I have 2,000 still left alone. Now we're going to do our exponential piece. So we're going to go 1.00225, raise it to the 20th power. And I'm just going to write it down so you see if you get the same answer as me. It's approximately 1.5605. We can leave that into our calculator and now just multiply it by 2,000. And we get $3,121 and about 2 cents. If we go back to our problem, how much we should have in our savings account after 5 years, if we assume that 9% stays the same, no adding of money, we are left with $3,121.02. The second question asked now is it's continuous, so we have a new equation. So remember our principal was $2,000. Our interest rate was 9%, so 0.09, and our time is 5 years. So we're going to plug those 3 things into our formula. A is our end amount, principal, our initial $2,000. E, that we'll be using our calculator for, 0.09, 9% for 5 years. So with PEMDAS, we want to do our exponent first, 0.09 times 5. 0.09 times 5 is 0.45. Now we do our exponential piece first. Second E, 0.45. I'll leave the 2,000 alone. And what you should get when you say E to the 0.45 is approximately 1.5683. I'm going to leave that in my calculator. I'm going to multiply it by 2,000. And I get $3,136.62.